Hi there, grade sixes. It is time to get back to work with something brand new in math. Okay, not brand new. This is stuff that you've done before, but we're going to do it differently. I know I keep saying that, but it's absolutely true. This is going to be a unit on measurement. And what I want to do with measurement especially is to get you to start thinking about how to apply measurement the way that, well, we do every single day. Okay, things like, can you use a 12-hour and a 24-hour clock? Can you figure out elapsed time? Can you estimate and count money to $10,000? Or develop formulas on how to do area and perimeter and volume of something? Can you relate cubic centimeters and cubic meters? Do you know what that means? Can you relate different units of mass? That kind of stuff. That is our ultimate goal over the next little while. So let's just take a couple of seconds to see exactly what I mean by that, by taking a look at some of the available ways of looking at, well, measuring. Here we go.
Okay, here are a whole bunch of things that allow us to do some kind of measurement. Okay, and there's measurements in more than just, you know, lengths and widths and that kind of thing that we would see here with this rectangle. There's measurements of time, and there's different ways of doing that. You can use traditional ways like you're using a clock or a calendar, but also this is a measurement of time too. If you think about it, the rings in a trunk show you how much time over which a tree grew, okay, and how old that tree was. There's a look at weight. There you go. You know, like how many elephants or whatever the case may be. And of course, there's volume and area and that kind of thing too, shown right here. Pi is used to figure out the area, say, of a circle, for instance, or you'd go length by width to figure out the area of a space. You've got linear measurements with rulers, but you also have measurements of angles, okay, and with different types of ways of measuring angles. Plus, you can take a look at time. Here's another example. The time zones of Canada, because time is different from where you live. Depending on where you happen to be from east to west, your time might be different. For instance, when the sun comes up in Newfoundland, it's a good 4 hours before it comes up again in BC. So to say that it's, you know, 2 o'clock in the afternoon in Newfoundland, for instance, it's going to be what? You know, 10 o'clock in the morning in British Columbia. It only makes sense. We measure time over a distance. Okay? So these things are the kind of stuff you're going to have to look at. So here's where we're going to start. We're not going to go right into learning. What we're going to try to do is get an idea of where our heads are. I want to take a look at airports. I want you to think about how an airport works, right? You constantly have planes taking off over various runways and going in each direction, heading off to many different destinations, arriving as well. There's many different planes working at the same time, but it's not just planes, it's people, and it's cargo, and it's all the things that are tied into an airport. In an airport, where would you use measures like time and mass and cost and volume and capacity? Can you think of as many examples as you possibly can of where you might use each one? Like, for instance, time is kind of makes sense. How long do you have to wait before you can, or be there before you can get on your plane? Is it a couple of hours? And if you get on a plane from here to, say, Florida, is it going to take you as long as from here to, say, Vancouver? Okay, so time is easy to figure out, but where would mass, cost, volume, and capacity come into everyday existence at an airport? Okay, so think of as many opportunities or as many examples as you can of places where that would be used as an airport. And I want you to think about something. For each one of these types of measurements, why would a staff at an airport need accurate measurements? Why would they need it to be as accurate as possible? Okay? That's what I want to see you have done by tomorrow. Come up with some good ideas, come back and we'll talk about them in class. All right? Good luck.